So for 31, we want to see whether this series is convergent or divergent, and if it's convergent, we want to find its sum. So now the fact that we have an n in the exponent tells us that this may be a geometric series, right? But it doesn't quite look like a geometric series, so we're going to have to adjust it. So what I'm going to do here is I'm going to rewrite this. So from 1 to infinity of 1 plus 2 to the power of n over 3n. I'm going to break this up into two different series because they have a single denominator, so I'm allowed to break it up. So I'm going to say that this is the sum from 1 to infinity of 1 over 3n plus the sum from 1 to infinity of, that's going to be 2 to the power of n over 3 to the power of n. So once I'm here, I'm just going to just rearrange this. So that's going to be from 1 to infinity, that's 1 over 3n. And I just put this 1 to the power of n because that's not going to change, but it makes it easier to visualize the ratio. And then plus, from 1 to infinity, I'm just 2 to the power of n over 3 to the power of n. That's the same thing as 2/3 to the power of n. So we can now see that this is a sum of two geometric series. So we have to remember that a geometric series, let me write this down. So geometric series is of this form here. And if the absolute value of r is less than 1, it converges. I'm going to say it converges, and the sum from 0 to infinity of a r n is equal to a over 1 minus r. Okay, so with that being said, we can see here that this is a sum of two geometric series, right? The first one, we can see that a, so this constant here that's being multiplied, well, that's just going to be 1, right? Because there's no number outside. And the ratio is going to be 1/3 because that's what is being raised to the power of n. So in this case, the absolute value of 1/3 is less than 1. So this definitely converges. Now, let's check the second one. Similarly, a is just the constant 1. And the ratio here is 2/3, and 2/3 is less than 1. So it does converge. Both of them converge because the absolute value of the ratio is less than 1. So once we're here, we can now apply this formula over here to find the sum for both of them. So there's only one thing that we need to do before we use this formula to sum everything up. The thing is, the index here, it begins at 0, whereas this index begins at 1. So what we need to do here is we need to adjust them. And this is how we're going to adjust them. So that's going to be the same thing as... So what I'm going to do here is, instead of putting 1, I'm going to put 0. And the way that I'm going to adjust it is I'm going to say, okay, this is 1/3 n plus 1. Which does work, right? Because the point is that whenever I plug in my first index, is going to give me 1/3 to the power of 1. So same thing here. If I put my index now at 0, but I put n plus 1, whenever I plug in 0, it's actually going to give me 1/3 to the power of 1 for the first term. So, but I don't want it to n to plus 1. I want it just n. So all we have to do here is remember that 1/3 to the n plus 1 is the same thing as 1/3 to the power of n times 1/3, right? We can decompose this power into a multiplication. So that's what we're going to do. So we're just going to say that, I'm just going to rewrite this. That's 1/3 times 1/3 to the power of n. Similarly, for the other one, I'm going to index it at 0. And then I'm just going to shift the index up 1. So 2/3 n plus 1, but now I'm going to decompose this 2/3 n plus 1 into 2/3 n times 2/3 to the power of 1. So that's going to be 2/3 times 2/3 n. Okay, so now we've gotten them to look like this here. It follows perfectly. So for the first one, we can see that a, maybe I'm going to highlight this. So a, which is the constant that's multiplying, is 1/3, right? And for the second one, a is 2/3. Whereas for the ratio, let me put this in a different color. The first one is 1/3 and the second one is 2/3. So for the first sum, we're going to have a, so 1/3 over 1 minus r, so 1 minus 1/3. And then for the second one, we're going to have a, so 2/3 over 1 minus r, which is 2/3. Let me just erase this so that we have enough space to work. So, yeah. And then, so this is the same thing as 1/3 over 1 minus 1/3. So that's 1/3 over 2/3. And then plus, that's going to be 2/3. All over 1 minus 2/3 is 1/3, which is the same thing. This is 1 over 2 plus, that's 2 over 1, which is the same thing as 5 over 2. 5 over 2. So this is our answer here for the sum of 31. It is convergent and we can find the sum. And maybe I'm just going to rewrite this because my 5 looks terrible. There.